Let's talk about binomial distribution and a normal distribution. The data from a binomial distribution are discrete random variables. The notation for binomial distribution: X follows binomial distribution with n as the number of trials. P is the probability of success. When we're looking for probability of specific value, we got to use binom PDF. PDF means the probability over a specific value. Normal distribution. Since the data is a continuous random variable, the shaded area under the curve is the probability. Therefore, for this normal distribution with the mean 10, we want to figure out the probability of x equals 4. The area at x equals 4 is 0. So probability of x equals 4 equals 0. In other words, no norm PDF for normal distribution or for all continuous random variables. Let's talk about CDF, which is a cumulative distribution function. It's the probability over an interval. For binomial distribution, if we are looking for probability over an interval, we got to use binomial CDF. Pay more attention to the domain of this x. It's greater than equal to 0, less than or equal to n. For probability of x less than c equals probability of x less than or equal to c minus 1. For example, we are given x follows binomial distribution with a number of trials of 5, probability of success 0.2. We are looking for probability of x less than 2. You got to change this into probability of x less than or equal to 1. Then we got to use binom CDF. 5, 0.2. Lower bound will be 0. Upper bound is 1. If we are looking for probability of x greater than 3, we need to change this into probability of x greater than or equal to 4. Binom CDF. 5, 0.2. Lower bound is 4. Upper bound is 5. So for this lower bound and upper bound, if you put in A, here's B, means this x greater than equal to A less than or equal to B. For normal distribution, this is the graph of normal distribution. You could say the domain for x is from negative infinity to positive infinity. Since this is a continuous random variable, probability of x less than c equals probability of x less than or equal to c. Why these two? equal to each other. We do know for continuous random variables, the shaded area is the probability. This area shows the probability of x less than or equal to 4. This shaded area shows the probability of x less than 4. You could say these two areas are equal to each other. So, the probability of x less than or equal to 4 equals probability of x less than 4. There are 3 types of questions for normal distribution. Type 1. Find the probability over an interval. We got to use norm CDF. For example, we are given x follows normal distribution 5 and 0.2 squared. We know this is a mean. Sigma equals 0.2. Then the probability of x less than 2 equals norm CDF. Lower bound is negative infinity. Upper bound is 2. Mu is 5. Standard deviation is 0.2. Then you put this into calculator to get the answer. For probability of x greater than 3 equals norm CDF. 3 is a lower bound. Positive infinity is an upper bound. 5, 0.2. Type 2 question for normal distribution. Find the data value A. We got to use inverse normal to figure out any specific value A. Remember, for this area means probability of x less than A. In other words, you are supposed to figure out probability of x less than A. Then you can figure out the specific value A. This probability of x less than A equals 1 minus probability of x greater than A. Type 3 question for normal distribution is to find the mean and a standard deviation. We got to use standard normal distribution. Z follows normal distribution with 0 and 1, which means mu equals 0, sigma equals 1. Here is the transformation from x to z. X minus mu over sigma equals z. Z means the number of standard deviation sigma above or below the mean mu. Above the mean, you will get a positive z-score. If below the mean, you will get a negative z-score. We will put the value of probability of x less than k into this area. Mu is 0. Sigma is 1. Then we can figure out this z-score. Then we use the formula z equals x minus mu over sigma to figure out mu and sigma.